We fully expected that we'd be able to produce high purity manganese sulphate monohydrate. And the real significance is that it really validates our strategy of developing the Emily mine and looking to produce high purity manganese sulphate monohydrate for the electric vehicle battery sector.
Welcome back to those tuning in to the Assay TV, where I'm delighted to be joined by Brian Savage, CEO of Electric Metals USA. Welcome, Brian. Great to have you.
Thanks, Katie. It's great to be here.
So just as a starting point, it's great to get a little introduction to electric metals for any unfamiliar viewers.
Oh, you bet. So electric metals, we've got the highest grade manganese deposit in North America. It's located in Emily, Minnesota. And what we're looking to do is develop that mine with the idea of producing high purity, high value manganese products, primarily for the electric vehicle and energy transition sectors.
Excellent. As you've just mentioned, the Emily project does produce this high purity manganese sulphate. For those less well versed with these chemicals, what is the significance of this?
Well, it's not unexpected because if we look at the previous metallurgical test work that's been done at Emily, they've been able to produce electrolytic manganese metal, electric manganese dioxide, and manganese carbonate. And so those are some of the high purity products. And so we fully expected that we'd be able to produce high purity manganese sulphate monohydrate. And the real significance is that it really validates our strategy of developing the Emily mine and looking to produce high purity manganese sulphate monohydrate for the electric vehicle battery sector. And it's a high value, high margin product.
Absolutely. And I guess looking to the future direction of the project, you've just released this report going through the key results from the metallurgical testing program. What will directly impact the decision-making processes in terms of future phases of the project?
Well, the very good news was that we had very high leach recoveries. We were getting plus 95%, as much as 98% of the manganese recovered in the leach. We also are able to produce the HPMSM to battery specs, from the Fast Markets 2022 benchmark. So we're very happy that we were able to do that. The other item that's very important going forward is we understand what the battery manufacturers and auto manufacturers are wanting, or I should say not wanting, in their impurities. And so we can take a look at those elements. And when we're doing our future ore reserve definition and metallurgical test work, we can ensure that we're specifically looking at those particular impurities and modeling those to make sure that we have a much better efficiency.
I guess looking at the broader picture, you've just talked about this high purity manganese. This naturally will enhance electric metals competitiveness in the clean energy transition market, I assume. Can you go through some of that with us?
Yeah, so the CPM group are forecasting a big shortfall of HPMSM kind of around 2030, 2031. And they're estimating demand of about 800,000 tons. Right now, 100% of it's being imported. There isn't any production in the US or Canada, for that matter. And so if we can have 100% domestic supply of HPMSM, that's an absolute dream scenario for these North American battery manufacturers.
Excellent. And you did touch on this a moment ago, but I guess what are the financial and operation implications of the leaching and purification efficiencies that you mentioned and that were demonstrated in the report, for scaling production?
Yeah, so the high leach rates we hope will relate into lower operating costs and better efficiencies. And so as we still need to do a lot of optimization work, but the very initial signs are that we get high leach recoveries, which is very good news. And then we have like I said before, we've got a really good idea of which impurities we really need to be monitoring and keeping our eye on. So when we go through that scoping study phase, pre-feasibility, feasibility study phase, we can make sure that we're keeping our eye on the most important aspects of that process.
Right, so we've got this report that's been released. You've been busy doing a lot of metallurgical work. What are the next steps in terms of metallurgical development for the project?
So we want to do a scoping study on the mine. We want to do a scoping study on the plant to get a better, or I should say, to give the market a better understanding of the potential economics of the project. We want to do a plant location study to look at where is going to be the ideal location for that plant. We want to tackle another more in-depth market study on not just HPMSM, but high purity electrolytic manganese metal and some of the other manganese chemical products. And then we've got a series of mineralogy optimizing the particle size so that we can get a better handle on our ability to use magnetic separation to separate the iron from the manganese. And we also want to be able to try to separate the silica. So we have three potential streams of potentially economic material.
Excellent. That actually rounds up our interview today, Brian. Thank you so much for spending some time with us. It's been very interesting to hear all about electric metals. And I'm sure we'll touch base again soon with some more news flow.
Thank you very much. I appreciate it.